Hello everyone, hope you are having a nice day. In the last class we have discussed about the brief introduction about what is a macro. In today's class we are going to discuss about the data structures and algorithm associated with a macroprocessor. So we'll be discussing about the three data structures used in macroprocessor and how the macro is processed step by step. Consider you are having a macro and what can be a nested macro? A macro and inside another one macro will be there m and m and. That means a macro defined inside another macro. If you are facing this situation, what happens here is when you are going for a 2-pass for macro processing, what happens is during the first pass, macro definition will be processed. In the second pass, the macro invocation statements, that means the programming statements, will call the macro. But when you have a macro inside another macro, it will cause a problem. That is, one macro has a definition of another macro inside it. When one macro has a definition of another macro in it, it will not allow one macro, the first macro, for example, when you are expanding the first macro, this outside macro, that means I have found a definition here. That means I will stop it and I will go for the second pass. During invocation, if the inner macro is called, it will become a problem. So 2 pass is not possible when you go for a macro processor. Clear? So this is a general thing, and in today's topic we will see the data structures and algorithms used. Data structures, and after seeing the data structures we will go for the algorithm. There are 3 data structures used here. The main data structures used here are, first one is definition table, second one is name table, third one is argument table. First one is definition table, second one is name table, third one is argument table. So definition table contains the macro definitions. So the macro definitions are stored inside the definition table, and in the name table the macro names are stored, and the argument list is kept inside the argument table. So we will see that one by one. So the 3 data structures involved are definition table, name table, and argument table. So if you can see here, see the first one is definition table. See, first you have a macro called as readbuff macro. These are the 3 formal arguments, and here you have the definition of the macro or body of the macro, and here you have end. Suppose if another record write buff is there, I will use here write buff. Then what I will do? Then I will use the arguments and the remaining contents will be returned. Yes, this is the definition table. The next one is name table. See, name table, what is name table? It contains the name of the macro. So if you can see here, the name of the macro is read buffer. So it has 2 pointers. First one points to the starting of the macro, and the second one points to the end of the macro. So from the name table I can identify where my macro starts and where my macro ends. The third one is argument table. I'll draw the argument table for you. So argument table can be like this. Suppose you have 3 arguments. The first one is in device. So the name of the device may be F1. Second one is buffer address. It can be buffer, as we have seen in the previous class. And third one is rect length. That means I am giving us length. Then these 3 are the contents of the buffer. Clear? So when you are expanding this, you will get these 2 things. Clear? So the 3 data structures are definition table, DEF table, definition table, name table, and argument table. So definition table contains the definition of the entire macro, name table contains the name of the macro, and argument table contains the arguments. Clear? So next, what is nested macro? See, nested macro means a macro that is defined inside another macro. Listen here. So suppose if you see line number 1 and line number 6, that means here you have a macro called as macros. Yes. Then line number 2 to 3, you have a read buffer macro, and there is a write buffer macro from 4 to 5. That means this read buffer and write buffer are nested inside macros. Clear? That is called as nested macro. So here the same, another example, macro X, read buffer, write buffer. This is an example for macro inside another macro. Now we will go to the algorithms. The algorithm is for macroprocessor algorithm. So here, when the opcode is not equal to end, that means what does end specify? End of the program. If the opcode is not equal to end, you can go for, and expanding is false. So what you can go for get line and process line. So we'll see what is process line first. Process line first, search for name. You are going to search in the name table. What is name table? It is a data structure. Suppose it is read buffer. You are going to check whether read buffer is present in the, if found, then yes, you have found read buffer. So what will be there? So I can put it this way. So I have something called as read buffer. Then I will be having 2 things. That is, first one points to the starting, second one points to the end. Then suppose if read buffer, the first one, if this is a macro, yes, it is a macro, then what you can do, you can write the source line to the expanded file. That means I can write the contents inside the defined record. That means entire thing can be written till I can write this emment. Clear? So you are going to search in the name table. Inside the name table, if read buffer is present, so consider you have a program, copy program. Inside the copy program, something called as macro or something called as read buffer comes like this, and it says F1 length and some other thing. If 3 contents are coming and we cannot understand what is that, what you have to do, you have to go and search in the name table. Once in searching the name table, if it is found, then you can go for expand. How will you expand? You can take the content from the definition table, because name table will show you the starting address and name table will show you the ending address. So till the starting address and ending address, I will find the value. So this is the process line. Next one is define. So what will you do in the defined record? So first you have a defined table. So first what you have to do, enter the macro name in the name table. So in the name table, so the macro name, suppose I will write, this is RD is the name of the macro, starting address, ending address. 2 fields are there. And first listen here, first you have a name table, enter the macro in the name table, then enter the macro prototype in the definition table. That means the content will be written here. Suppose this is read and the content, all the content will be written, then emend, this is written. Listen, yes, Now these two lines are complete. Now level is equal to -1. Now listen here. Then you have to go to get line. Get line we'll see get line next. Then here what we are going to do is, first line, you are going to enter the lines, first line, second line, third line. So when you are entering the lines, if it is macro and you are entering the lines, level is equal to level plus 1. So initially level is equal to -1. Level is equal to level is -1 plus 1. Now level is equal to what? 0. Now listen, when you are entering the contents inside this, the -1 level changes to 0. If opcode is equal to macro, that means for read buffer, the opcode will be macro, read, macro, and something. When you are entering this, so when you are entering all the contents, it will be 0. Then, if opcode is equal to end, that means when you reach the end, what happens now? 0 minus 1. Level value is, now it is 0 minus 1. Now it is changed to minus. It goes to the previous state. So now what I can do is store the name table pointers. So here the starting definition, that is when it becomes 0, that is the starting definition. So the name table will point to the first position. When this level is 0, when the level has become 0 initially for the first time, that is given as the starting address. When the level has become -1, after it has become 0, the level will reach -1 for the next again. That is the ending address. So can you understand here? So what we are doing is, when you are expanding, first we have to find if there is a macro definition. If the opcode is equal to macro, the level value is level equal to level plus 1. That is, initially it was -1, -1 plus 1, it becomes 0. Then when it reaches end, again level is equal to level -1. Level is 0 minus 1, it becomes -1. So the condition here is, when it becomes 0, that means we have started a macro. So what I can do from read buffer, so I have a name table. So you have a name table. The name table contains your macro name and 2 plots. So first part, so when this reaches 0, that means during the starting it has reached 0. So I'll write that. And sometimes in the last position it reaches -1. That is end position. I'll put that value here. That is how you can find the starting address as well as ending address. Clear? Next. So we are going to see 2 more things. Expand. So what is expand? Expand means, for example, you have in your program, you have found a macro definition, for example, read buff, and then 3 parameters, actual parameters has come, 3 parameters, f1, buff, length, 3 things has come here. Now what you have to do, you have to expand this macro. So I'll take the actual arguments and I will put in place of the formal arguments. Instead of formal arguments, so what you will do, you will just involve the actual arguments, and that is called as expanding. Clear? So from where will you get the arguments? So the arguments will be taken from the argument table. Arguments will be shared in the argument table, and corresponding arguments will be taken from the argument table. Last one is get line. Listen here. So get line means, here if you are expanding, then you have to get the next line from the macro definition from the definition table. So suppose if you have taken the first line, then you have to get the next line from the definition table. Substitute argument. For example, f1 may be used in the 4th line. Instead of f1 in the general definition, I may have in device. So instead of in device, what I have to do? I have to put this f1 here. that is expanding. Clear? Then read the next input line till you reach mint. So this is about the algorithms used in macroprocessor. So in today's class, we have discussed about the 3 algorithms that were used in our macroprocessor and different algorithms used. So the algorithms helped us to expand a macro and how that macro was expanded. Hope you understood this video lecture. Thanks for watching. Thank you.